negative 10 meters. So x sub I is equal to negative 10. Has a velocity of plus 2 meters per second from 0 to 2. So I'm going to record that here. Velocity from t is equal to 0 to t is equal to 2 is going to be plus 2. And then we have a velocity from t is equal to 2 to 8 seconds, where it's plus 4 meters per second. And then you have the velocity from 8 to 10, where it's negative 6 meters per second. So the problem asks us, what is the value of xf? So there's two ways you could do this problem. The first way is you can literally draw this graph out, and with all the boxes, and make sure you draw it really well, and you can count how many boxes are going each way, and you can find out an xf value. The other way that you could do this is you can apply this relationship. X is equal to vi t, because there's no acceleration in this problem. So you can ignore the plus 1/2 at squared and only focus on this. This is plus xi, plus your initial x value. This is going to become really handy. So we're going to solve for x final here, x final here, and x final here. And when we get to here, this will be our answer. So for the first part here, we'll get x is equal to our initial velocity, which is 2 meters per second, times 2 seconds, because 2 seconds have elapsed, plus negative 10, because that's where we're starting, meters. So 2 times 2 is 4, 4 plus negative 10, we should get negative 6. So that's here. So xf here, negative 6 meters. So now we're going to find out what's the final displacement at 8 seconds, using this value we just found as our new initial. You plug in the exact same equation. So we're going to say x final is equal to x initial plus vit, where our initial is now negative 6, plus, and we have our velocity here of 4 meters per second, times our time. 8 minus 2 is 6, so that's times 6. So 4 times 6 is 24. 24 minus 6 is going to be 18. X final is equal to 18 meters. Now, we're going to find out what its final is at the end of the 10 seconds. So we're going to go over here. We're going to the exact same equation. X final is equal to xi plus vit. We're going to plug in our values. We're going to plug in 18 for xi, plus our velocity, which is negative 6, times our time. 10 minus 8 is 2. So we have 18 plus a negative 12, which will get us 6 meters, which is your final displacement, and is D. The answer to 4 is D. Does that make sense how I did this? Okay. Yeah.
I got from up to where you got negative 6, and then the second one
Right.
was xi initial, which was the previous negative 6.
Right.
Plus
Plus the velocity of the second part of motion.
which was the 4, which was a positive 4.
Right. Times the 6 seconds that we were in that motion.
Oh, okay.
Yeah. So, because one of the big things in kinematics and really all of 114 is that motion has to be treated separately if variables change. So if we have a sudden change in velocity from like 2 to 4 with no real acceleration, then you have to split those up. So you handle that separately. And that's what we did in this problem. Does that make sense? Awesome. Okay, we're going to go to question 5 here before I hand it off.
It's associated with this question.
It's associated with, oh, whoops. Well, whatever. know the answer. The net displacement magnitude at t equals 10 seconds is perfect. Okay, so we know that xf was equal to 6 meters, right? So our net displacement is going to be given by delta x is equal to, move that over, put it over here, delta x is equal to x final minus x initial. So if that's the case, we know both values. We know 6. We know the initial was negative 10. So 6 minus a negative 10 is going to give us positive 16 meters. So the answer to number 5 was C. Does that make sense how I did that? That's just any sort of time where it says asks for net in terms of displacement or velocity. This is what you should do. Awesome. So I'm going to hand it off now to my esteemed colleague. He's going to do questions 6 through 10.
Sure. Are we changing the video?
No, since the sixth question is really short.
Sure. There's 2 conceptual questions, 6 and 7, but doesn't necessarily mean that they're not important, because 6 is important to the question that you just asked me and going about answering number 10. So when you throw a ball up into the air, have we all learned by this point that it follows a parabolic path? This is because in the y direction, gravity is working, and in the x direction, nothing is changing. It has an initial velocity in the x direction, so it goes that way, and that doesn't really matter to how long the ball stays in the air, because what matters is this component, the VIY. That is the initial energy that will launch it into the air. Energy will become important later, but right now, it's best to remember the velocity has to change signs at the top, because it doesn't go higher anymore, it starts to go lower. So since it changes from a positive to a negative sign, it goes all the way from positive 3, positive 1, 0, negative numbers. So at that point, if you want to think about it in calculus, the derivative or the slope is 0. The 1/2 of path equals 0. And the number 6 question is about this schematic, that the maximum displacement in y is at the point that the velocity equals 0, and it turns back around and starts coming closer to you. Number 7 is this principle all the same. If you were to have 2 forces like that accelerated a ball in this direction or that direction, the question is worded such that golfer A's ball has 10% smaller initial upward velocity than golfer B. So the initial velocity of golfer B's ball is more looking like this force vector than that. And it should be in the air longer. I didn't see the answer to that one. The answer to 7 is B, right?
It's written wrong on the test. Like he changed it.
Oh, he said that it was supposed to be the golfer B is supposed to go in an initial horizontal velocity rather than upward.
So the answer is A, but the takeaway is which, if you were to break it down into vectors, the force component of the y. Whichever force component of y is bigger is the one that will be in the sky the longest.
Sorry to be annoying, but on number 6, really fast, do we just have to assume that when it's talking about displacement that it's only regarding the y-axis? Because it doesn't really, it just says maximum displacement. And technically if it was like x maximum displacement, then
That's
it
a good
would be
point.
zero, right?
Well, you hear that question? So, say it again.
Because I understand how like max displacement on the y scale, then the velocity would be 0. But if it was the max displacement on the x scale, then it wouldn't be 0, would it? Like if you were
Yeah.
going.
If you were to just exclusively think of the x scale, then its max displacement would be when it eventually stops in the x. However,
Unless it goes back.
the displacement is a maximum when the velocity is 0. I think that in the context of this problem it says vertically up,
It's just,
maximum height.
okay.
That's kind of the clues there. And also, the question you asked involves a lot more mathematics,
Okay.
which I can do if you want to stay after. 8 is, I already went over this.
Just a second.